Hello everyone, in the series of learning aerodynamics, in this video lecture let us discuss a problem on the aircraft performance, because in the previous video lectures we have seen how to we have seen some of the important equations and derivations to be used in the aircraft performance. So now in this class we will see about the problem, that means numerical problems, okay, how to solve these numericals. And before that, let's see how to get this equation, because we are going to use this equation for this problem. So we know, okay, from previous class, okay, and that we have seen that d by d minimum equal to 1 by 2 m square plus m power minus 2. That means this equation, this derivation expression we have derived in the previous class. So from this we can derive this one, means we are just replacing, we are just obtaining from this, we are just coming to this, and then we just, what we are doing, just we are instead of d by l we are putting, so l by d, that is this one l by d, and this is also bottom also l by d. Numerator and denominator we are replacing, instead of d by l we are replacing l by d, this is okay, this is l by d, this is nothing but minimum drag, so we can say as the l by d max, so that is equal to cl by cd, then by this, so in by coefficient form also we can write, and then that is equal to this, then okay, this one, okay, it is 1 by 2 m square plus m power minus 2. So now, okay, we have taken the reciprocal in the numerator and denominator, and same thing here also we have to take the reciprocal, here also we have to take the reciprocal. So reciprocal of this nothing but 2 by m square plus m power minus 2. So this derivation, that means this equation we are going to use for solving this L by D ratio at other speeds. So first let us see the problem. So the problem says an aeroplane has a wing loading, so wing loading of 2400 Newton per meter square, and the drag equation is given by CD equal to 0.016 plus 0.055 CL square. So we have to find the L by D, maximum L by D ratio, and velocity at minimum drag conditions, then L by D ratio at other speeds, nothing but here the particular speed is given, this is nothing but aircraft speed or flight speed we can say, and then this is going to, we are going to obtain all those things, we are going to obtain at the equivalent airspeed, because equivalent airspeed is nothing but it is the sea level, that means it is equivalent to the sea level conditions, whatever, okay, exist at the sea level condition, that that data, okay, so we have to use it. So for solving this problem, so we will be using the sea level conditions data. So first thing, okay, we will see what is the given condition. So the given condition, we can just say, or given data, so nothing but in this, so given data we know that W by S, wing loading, W by S equal to 2400 Newton per meter square. Then another one, CD value, that is a drag polar equation, so we can just say CD equal to 0.016 plus 0.055 CL square. So we all know that this value, say this is nothing but our CD naught, so CD naught, and this is nothing but K. So yeah, so now we got the, okay, we have the this data. So for now, okay, we have to find out three things. One is a maximum L by D ratio. First let us see how to find out that maximum L by D ratio. So maximum L by D ratio, we all know that formula is nothing but L by D max. So L by D max is nothing but we can use CL minimum drag by CD minimum drag. So this is nothing but square root of CD naught by K by 2 CD naught. So we can, because we know the CD naught and K, straight away we can substitute these values. Then we can just say that so we can substitute here the square root of CD naught is nothing but 0.016 by K is nothing but 0.055. So whole divided by 2 into CD naught nothing but 0.016. So now okay, this is what L by D max. So L by D max nothing but this. So this is equal to this value, just we will be getting around 16.84 or 16.85. so this is what L by D max. So now we got the L by D max. Then let us find the velocity at minimum drag, that means minimum drag velocity. So now let us erase this. So yeah, so we can erase this also. So yeah, so you just have a minimum drag velocity, so nothing but V minimum drag equal to square root of, this is what the formula, 2 by this rho CL minimum drag. So we know just okay, straight away we can substitute the values. 2 into W by S nothing but wing loading, so nothing but 2400 whole divided by rho is nothing but sea level density, that is 1.2256. CL minimum drag, we know the formula, CD naught is nothing but 0.016 divided by 0.055. So after doing the calculation, this value velocity, that means minimum velocity at the minimum drag condition, so that value comes around 85.21. so that velocity, that means we can just say minimum velocity at minimum drag nothing but 85.21 meter per second. So now okay, we got the minimum drag okay velocity. Now okay, one more just part is left out. So velocity, that means L by D ratio at other speeds. So that is for that okay, we have to use this formula. So L by D ratio at other speeds, we can just write that means L by D ratio by that L by D ratio max, that is equal to 2 by m square plus m power minus 2. So here m is nothing but we all know, so m is okay, so m we can find out, m is nothing but v by v minimum drag. So this value okay, we know velocity, that this v is nothing but flight speed, that is 100 by v velocity minimum drag 85.21. so this will be okay, this is around 1.1735. so this value is nothing but 1.1735. so now we got the m value, so this m value directly you can substitute here, and then we'll be able to get the value. So yeah, so we can just say it means yes, so just L by D ratio, L by D ratio max, L by D ratio equal to, from this we can just write L by D ratio equal to 2 by m is nothing but 1.1735 whole square plus 1.1735 minus 2. so this L by D max, so that will do the multiplication, cross multiplication into L by D max. So this is nothing but so L by D ratio at other speed nothing but 100 meter per second, that is equal to 2 by this ratio, this value alone comes, this value is something around 0.4754, this is 0.4754, this value, this around this value alone, into L by D ratio, maximum L by D ratio nothing but 16.85. so by doing this calculation we will be getting around this L by D ratio equal to 16.02. so this is the value. Okay, so we got the all the three values, that means LBD ratio at other speed nothing but 100 meter per second, and then velocity at minimum drag that is nothing but 85.221. Then maximum LBD ratio nothing but 16.85. So I hope